Hello, my name's Paul Johnston. I am CTO of a company called Movivo. I am also a former consultant CTO, so this is a proper job. This isn't me being a consultant. And I've basically spent a long time messing around with AWS. Messing around. Most people look at AWS in certain ways, and this talk is kind of, it could be subtitled, well, I've put How to Go Beyond the Monolith. It could also be subtitled Beyond EC2. So just out of interest, how many of you quickly use AWS in your everyday lives? How many of you use more than EC2 and RDS and S3? About 6 of you. Okay, that's fine, that's good. This is a good talk then for you lot. So a little bit about our company. We are a very small startup. Someone asked me how big our engineering team was. It's 2 at the moment. It's about to be 3. But we basically have an Android app that goes into developing companies in emerging economies. We allow people to download stuff, do tasks, and earn free internet and airtime. So essentially, if you imagine that you've got a pay-as-you-go phone, you do a few things and you get a few credits and then you press a button and it tops your phone up. That's pretty much what we do. We do it in 14 countries and we've had over 1 million installs in less than a year. So that's what we do. I was brought in as the prototype to, I was brought in as the CTO to prototype the app that we had kind of half created. And also to do the back end. And when we started, there was kind of, I basically spent the time and talked to a lot of my friends, CTOs and others, who basically said, oh, you just need to use AWS. And what they meant was EC2, RDS, and S3, and a couple of bits and pieces around Route 53. And I was very used to that, and it was a very normal thing to say, and people were very clear about, the way that you are supposed to do things is you are supposed to just get your EC2 instances and auto-scale stuff, or use Heroku. And then everyone started talking about containers, and it was all getting very exciting, except it's all exactly the same thing underneath it all. You're still doing the same things. And we've spent a long time using these services in the same ways. Actually, when you look at what EC2 is, it's essentially a virtual server, and a virtual server is a virtual version of a server. So essentially, we've been coding the same things for about 25 years. We haven't actually done a huge amount different. When you use EC2, you're essentially using the same thing as if you had an actual box sitting on your desk, which makes it easy to do things like develop and manage, and you can understand it. And as long as you've got a command line, we're not even going to go into Windows. If you've got a command line with Linux, then you can do essentially the same things as you can any other time. So when I started looking at this was kind of, these are things that are gateway drugs. You start doing cloud, you do this. This is what you do. This is what people think cloud is. So I basically went, right, I'm not doing that anymore. I'm going to go serverless, and I'm going to use AWS Lambda, and I'm just going to have a go and see if as a startup, if it all fails and goes wrong, I'll give it 3 months and see what happens. But essentially, that meant that I had to deep dive into a whole bunch of other things and a whole bunch of other AWS services. Just quickly, I do not work for Amazon. I do not. I'd love to. It would be lovely if they're here. No, but I don't. I'm not going to make any money out of that, and I'm not going to make any money out of anything. I like talking about this stuff, and it's exciting. I actually want you guys to think about AWS in a different way and cloud in a different way, so that I can hire some of you later on. This is one of the things I was talking with a couple of guys earlier about. I cannot stand frameworks. I am a chief technology officer. I cannot stand frameworks. There is a very, very good reason. They make you lazy. You basically end up going, I'm going to just pull off the shelf this piece of technology, and it's going to have an ORM in it, which means I don't even need to think about the database. And so that's come in as well. And then I've got session management. I don't need to think about that. And then I've got, all these other things that I don't need to think about it. And you just go, and there's a server, brilliant, and just plonk it on. And that's what people do. But actually what it means is that you don't necessarily understand what you're doing and why. You are reliant upon as yet unknown people who have built a whole bunch of things that you're not entirely certain why they built them, but it sort of works in the way that you hope it does for the use case that you have. Now, I'm not saying that using a framework at any time is wrong, but use it for the right reasons and for the right purposes. And we've had to kind of push this idea anyway, because a lot of the things with AWS are that you actually have to step away from the one thing, the monolith, to actually start to use all the different services. And as soon as you start going monolithic again, big code, big frameworks, what you actually end up doing is using the services badly. And here's why. They're built for servers. They're built for the coding and the thinking that was 25 years ago when we started doing stuff on the internet, and we first of all got Apache, and we had, Red Hat 4. That was what frameworks were for. It was because we didn't have the capabilities of doing all of these clever things. So stepping away from a framework is actually probably the most important part of anything to do with AWS. And it might seem a bit strange that I've started here and I'm going the other way, but it's actually turned out to be very important. And when you think about AWS, you've got to think about a set of services. And those services do what the frameworks do. So instead of having the one piece of code that you go, right, that's how we're going to work, you go, right, and you split it out, and you have to do bits and pieces. It's just talking about AWS. Not every service is equal. You don't always use every service. You don't do, some of them are far more useful than others. So don't just use them because they're AWS services or any other, this is completely applicable to other cloud vendors. I'm not I love AWS. I've been using it for far too long, but I'm just saying it's not the only thing. But recognizing that's quite important, but also recognizing everything is an API. So instead, you kind of have to step away from visual interfaces as well. You have to start thinking about everything as an API, everything as an SDK. And it's quite an important step to make. And so one of the things we use very heavily is AWS Lambda. And the last point is actually quite important. AWS Lambda is perfect for about 95% of use cases. But if you want to do something with very low latency, it's probably not a very good solution. You probably need something different. So understanding the service tells you how you should use it, not just use it because it's there. This is what we've done for years. I'm kind of going over a lot. I'm going to try and speed up a little bit because I want to give you time for lots of questions. Is that okay? Has anyone got any questions already? No questions at all? Okay, fine. So what we normally do when we think about deploying a solution is we do 3-tier or n-tier, depending on however many other things you want to add into here. So you've got your presentation layer, which is your templates or whatever it is. You've got your business logic, so your controllers, and then you've got your data. Woohoo, it's a database. And that's what most people do. And usually what we do is go, well, we'll just stick some kind of framework in here. We'll just have a framework, and that'll handle that, and it'll give us a way of handling that. And essentially, your framework does the whole thing. So when you come out to AWS, you kind of have to go, how do we change from this model to something else? Because that's what you end up with when you build everything. So I'm kind of missing a couple of bits out because a couple of conversations earlier, I think it's more important to talk about a few things going forwards. So the problem with a monolith, the problem with a big solution is you can't debug it. Actually, what you end up having is technical debt throughout the entire solution. So, for example, someone else is managing your session management, or someone else is managing the way that you authenticate, or someone was mentioning earlier to someone who had downloaded a library and done authentication but didn't know what token-based authentication actually was, but it still worked. So it doesn't matter, does it? Or doesn't it? I would argue that it does matter. So the way that you have to think about this is, so to step away from the old school and go to the new school is you have to move away from EC2 and scaling to something completely different. And what that completely different is a different way of thinking about infrastructure. You have to stop thinking about your frameworks and start considering AWS as a foundation. So instead of having, you're not building a pyramid, you're not building a pyramid and the foundations, you're building the pyramid on the foundations. So your AWS services turn out to be your foundations much more readily. So AWS, some of the things that people never use, that we're now kind of getting into the meat of the AWS bit, by the way. Just, are you all with me? There's a few of you kind of going, and I'm kind of, have we all got the idea that frameworks are not good anymore? Hands up, everyone? Well, good, brilliant. Okay, so I've got one thing across, that's fine.
More and more industry is moving towards frameworks, so I can't relate to that one.
Okay, that's fine. We'll talk about that later, actually. So some of the things that you can do with AWS. So who has used Elasticache? Who even knows what it is? Oh, there's about 8 of you in the room. Okay, do you all know what it is and you're all just bored? Is that... No? Okay, no, we were fine. So when you use servers, you use memory. And when you have multiple servers, you use memcached. But you still have to run your memcached somewhere. This is memcached, but it's as a service. Bet you didn't know you could run memcached as a service. It's actually really helpful because you don't have to even consider anything to do with managing your memory and your little key value stores that are really quick. It's really useful. Route 53. Who hates DNS? If you don't put your hand up, you've never used it. DNS is a nightmare. It's understanding it, how to use it and everything else. It's actually really problematic.
It works. It's okay when it works.
It's okay when it works, but setting it up and changing anything, just don't.
Oh,
it's horrible. Route 53 is actually one of the best solutions I've found for DNS. It's not perfect, nothing ever is, but it's actually really, really good. And because it's programmable via an API, you can actually do some really clever things like rerouting things due to whatever you want, your own kind of thing. So useful. S3. Who has? You must have all used S3. Come on, please tell me you've all used S3. Good. A few of you have used S3. Fine. S3 file storage. Sounds like you would never need it, but basically, if you are serving anything via the web, that is, for example, JavaScript or CSS, and you are not using CloudFront or another CDN of some description with S3 behind it, then basically you're wasting your time. It's so much faster and so much better. I can't see a value in not using it. There are reasons not to, obviously, but if you know those reasons, then you know why you should or shouldn't use it. So, did I just jump across 2? No, I didn't. So nowadays, one of the things that matters with services is communication between those services. So when you've got your AWS and your Lambda, you've got your EC2 and everything else, what you want to be able to do is communicate between different services. Now, when you're talking about a service-oriented architecture, who's heard that phrase and hates it? Good. Let's not worry about SOA as a title. Let's think about it as an idea. Essentially, you need some way of having events and you need some way of having messages. AWS has that. It has Kinesis, which sends your messages left, right, and center and does what you want. It's also a very good way of separating out services. If you imagine your frameworks and your monolithic applications that you build, what you end up doing is you have an object here and an object here and an object here, and they talk to the database over there, and they do a whole load of things over here on your file system, and they're all basically a bunch of spaghetti hooked together by method calls. When you go towards service-oriented architectures of a sort within the AWS environment, you basically have to have something like Kinesis, which does the messages backwards and forwards for you. It means you have to separate out the code as well and separate out the bits. So you can't do the same things you would normally have otherwise have done. There are problems. So when you've got a monolith, you can see what's going on and you can follow it. And your IDE can press a button and you can go to the right bit of the code. You can't always do that with services, but there are ways around it. So who has heard of Cognito? Now, I know at least 2 people have. Good, about 7 of you. Right, Cognito, authentication, and to an extent authorization as well, is actually really, really useful. We have to otherwise code a whole bunch of stuff around social programming and social authentication, and we have to store tokens, and this does it all for you. This is pretty much drop in and go. It's one of the most useful bits of technology that AWS provide, and hardly anybody uses it. So I'm just trying to see if I've missed anything on this slide. I think one of the problems I have with most of the ways that applications get built nowadays is if you build the entire infrastructure yourself, you are responsible also for the security. When you are a CTO, you are bothered about that because actually, have you hired great people to go and do the work for you, or have they just gone and downloaded a library? If you're really bothered about it, this is the kind of situation where you want best of breed and best practices to be taken on board and understood and used. This is the kind of solution that you don't want to implement yourself unless you are very, very, very good at it. So from a CTO's point of view, you are looking at the risk factors, and using something like this gives you a whole lot better risk scenario than if you built it yourself. So there's a few bits around that, but Cognito is definitely something we should touch upon. DynamoDB. Who's used DynamoDB? Who's used Mongo? Who likes Mongo? Nobody likes Mongo. Does that mean you don't like DynamoDB?
I like it even less.
You like it even less? So here's what I think. I think document databases get a bad press because everyone uses them with ORMs to start with. The problem with DynamoDB is if you use it with an ORM, you are using it in a terrible way. It is not supposed to be used in that way at all. So let's just kind of get one thing straight. DynamoDB is not supposed to be used with an ORM, which basically means if you have a framework and you have an ORM built in and you start to use DynamoDB, it's going to be terrible. So don't do it. DynamoDB is meant to be used in a different way. The way that you code and the way that you think about this data, you have to start thinking about the data in terms of what you want to get out. The background is that we all used relational databases. Who knows how to normalize a database? Really? Why is everyone's hand not going straight up? Because really, are there people that do not know what normalization is? Okay, that's fine. So we've always spent the time going, let's take our databases and let's stick everything in there and we can get everything out with a SQL query and it can do the work for us. When you're trying to use everything as a service, what you're trying to do is reduce your maintenance. When you've got a database, a relational database, you have a heck of a lot of maintenance that goes along with it. Maintaining the data, migrating the data, managing it, making sure everything's right. When you have a document-based database, you actually have to change your mindset towards being a every single table is usually write or read, not both. So you basically have to optimize your tables for write or optimize your tables for read. We primarily optimize our tables for read because we're doing a lot of queries on a lot of data. And what we'll usually do is chuck things into a database table, and then we will process it into what we want later on. So there's important things there. DynamoDB gets a very bad rap, so does Mongo, although the problem with Mongo is there is no service for it. DynamoDB is a service. It is not a database. It's a service you use via an API, and it's actually hugely, brilliantly wonderful, and I can't love it enough. It's what's made our startup work. And we have got a lot of, ask me later. By the way, there's going to be time for questions, so there will be questions about this. And you will hate me about stuff. Who's used AWS Lambda? About 6 of you, 7 of you. Okay, who likes AWS Lambda? Oh, excellent. More people, that's odd. Yeah? It sounds interesting. Right, okay, well, we can talk about this. AWS Lambda is has made me completely reevaluate how we should do software, and it's made me reevaluate it in a very, very good way. AWS Lambda is possibly the most important technology change that we've seen in the last 25 years, and I'm not being over the top on that one. The idea of function as a service, everyone happy with me saying function as a service? Out of interest, does anyone not know what Lambda is? Because it's probably worth explaining it. And don't worry about putting your hand up because there will be good. Fine, I will quickly explain it. AWS Lambda is a service where instead of providing a whole bunch of code, you put in small functions, and those functions are run one at a time in tiny little containers. And they can scale horizontally massively. So instead of having a server where you put all of your code that then scales, you only scale the bits that actually matter, the bits that actually will use up a lot of processing power. So instead of scaling your entire thing, it will scale only the bits you need. Yes? So is anyone confused by that? Okay, that's fine. It's fine, we're there. I think AWS Lambda is alongside API Gateway, which is a layer, essentially an HTTP layer between the two. I think these two are the two things you should probably go away and look up and practice and play with over the next 2 to 3 months, because you will be hearing a lot more about this over the next year or two. When you are building applications for these in the future, instead of getting a framework, sticking it on a server and allowing that thing to, like a Heroku, if you want containers, instead of doing the whole thing in one, actually this allows you to scale very, very carefully and very, very quickly in certain ways. Now, the downsides of it is that the way that most people approach it is that they approach it from, well, I've done frameworks, so I'm just going to stick a minimal framework on top of Lambda. Problem with that is that actually takes a long time to load, and it looks like you get terrible performance, and it also looks like it doesn't really work as well as if you just stuck it on a server. You have to change the way that you think. You have to change to a much smaller code base. You stop using frameworks, and you actually have to be a good developer to be able to do that. I can't stand frameworks, and I can't stress that enough. You basically have to start thinking about what's the best way of explaining it? What have I done in my notes? There are a bunch of rules. I've written a blog. Google it. I've written a set of 10 rules. Things like only do one data transformation per function. You know how when you do a normal thing, you will do one database call, you'll get some data back, you'll do something else, you'll get some data back, you'll then do some processing and put something back into the database. If you do that, Lambda doesn't work very well. But if you do a single process, a single thing, and then push an event into a queue, and then do something else off that queue, and then do another event off that queue, it works brilliantly. It's the point that I'm trying to make is this is not EC2 but small. This is use the technology, understand it in the right way, and then use it in the right way, and it will reap so many dividends. We had a piece of technology. We only have one EC2 instance. Everything else is in Lambda in our startup. We had 9 million API calls, which isn't a huge amount. In July, it cost us 61 cents. Okay? It cost us 61 cents.
How many?
9 million. Normally, if you're doing that another way, you'd have an EC2 instance sitting there somewhere. It's going to cost you, even a small one's going to cost you, what, $30, $40, something like that. 61 cents is 2% of the cost of an EC2 instance. All I'm saying, it's not perfect, but the benefits in terms of scalability, it was significantly better latency, and a whole bunch of other things. It makes a huge difference to us. It makes a huge difference. There are issues, and I've already primed someone to ask me a question in a minute. So when we look at AWS, EC2 and containers are not the answer anymore. Servers are not the answer anymore. They still work, and actually if you needed to do a whole bunch of stuff, You can still do all of those things. It's not a big deal. But actually, my opinion is, and it's an opinion, I'm not, I say I won't necessarily be right all the time. But my opinion is that we need to consider how to do things very, very differently. And if we do that, and if we use the tools in the right way and understand those tools, we can actually end up in a significantly better place with better scalability, lower maintenance, and I can't tell you how much maintenance I have to do because it's almost none, because we don't have the technical debt of frameworks and we don't have the technical maintenance of a server. All of those things just disappear, which sounds like magic, but it's really not. You think about the amount of time you spend upgrading your servers and upgrading your libraries and upgrading your frameworks and having security vulnerabilities because someone else has found something in a well-used framework. Those kinds of things disappear. I look at AWS as a foundational infrastructure. When you're looking at a whole solution, AWS gives you a significant base. Normally what people think of now with EC2 and servers is very, very low level base. It's just a server. AWS and the other cloud providers do now give you that whole framework and scalability that most people don't even touch. So that's how we think about it. I think that over the next year you will be doing a lot more of this stuff. And I think EC2 will become less interesting and servers will become less interesting over time. But I think AWS is awesome. I don't work for them, but thank you very much. And I have a blog. Please read. I've got lots and lots of posts on serverless technology. But I wanted to give a lot of space for questions because there are a lot of questions around all of this. And most people struggle with thinking about all of these things and how they fit into their particular scenario. Q&A. Go.
Hi. Very interesting talk.
Thank you.
Can you tell us a little bit something about the code deployment to such infrastructure?
Code deployment. Code deployment. So in a normal scenario, a code deployment is essentially your entire code base goes up in one go. And that's nice because you can test around it and you can do a whole bunch of stuff around it and it makes it work really nicely. Code deployment is a lot more complicated because you've got a bunch of services and a bunch of servers that are not necessarily yours that are running. So the way that we do it is that we have, has everyone heard of Terraform? Good, I've got some nods. This is good interaction. We use Terraform. So we have got in fact, they don't support everything yet. So they don't even support the whole of AWS. So there are certain bits that aren't in it, like Cognito is not. But our single EC2 instance that we have, our entire Lambda, our entire IAM permissions, roles, our API gateway, all our Lambda functions, DynamoDB, SNS that we also use, all of these services are within a single Terraform repository. And we have developed a CI system. So we use Circle CI so that whenever we deploy to, whenever we push, thank you. There's a word there, and I'm like, that's the one. Push to our GitHub repository. Circle CI will pull it down, test it, because we've built unit tests across it, and then it will push it into a staging environment, and then we have a separate process for live.
So we have different environments as well?
Yes, on separate AWS accounts, so they can't cross-pollinate. So yes, go.
Do you use Node or Python?
When we started, which was just over a year ago, most of the code samples and most of the tutorials were in Node, and my decision back then was Node or Python. We used Node, and we still use Node, primarily because there's more people that do Node, and we have other requirements. As I said to someone else, if I could go back and do that again, I'd pick Python. But the tools for Python weren't there a year ago. So if I was making the decision now, I would pick Python. Does that make sense? So in the context of a year ago, Node was a good decision but in the context of now, if you were picking it, you'd go with Python. I would go with Python, but that doesn't necessarily mean... you had your hand up earlier as well. Go on.
And how do you monitor it? Just cloud-wide?
Monitoring. Yes, one of the problems with Lambda is monitoring, and we've had real problems with monitoring. But not, well, real problems, but not really big problems. You basically monitor everything on a Lambda by Lambda basis through CloudWatch logs, and that's fine. It's one of the things that the community in terms of Lambda and serverless as a whole is working on, because if you imagine you don't have anymore a way of SSHing into a server, because you can't do that, and you can't do tail -f, var log, whatever, and actually next time you do tail -f on a file, realize what you're doing. Because it's actually really, you do an awful lot more than just looking at what's going on. You recognize that things are slow, you also identify issues much more quickly, and it's a thing that's actually quite hard for a computer to do. So you lose some of those abilities of things that we've learned over 25, 30 years. And so you have to learn different patterns of managing them. Does that make sense? Yes?
You mentioned Kinesis
Yes.
as part of the stack there. We, perhaps most people use SNS plus AWS.
Yes. Yep.
Can you explain the benefits of Kinesis over this?
Okay, so I've written a blog post on that. So I had a long chat with AWS about this about 6 months ago, actually. And one of the things that they say is SNS is push, SQS is pull. So they're the two queuing systems of a sort within AWS. Unfortunately, neither of them are actually very good as queues, which might sound odd when you've got something called the simple queue service. So we actually came up with a different way of doing queuing within the scenario, which was we have a DynamoDB table. This is, by the way, this is something that AWS think is a really good idea, but they still haven't written the blog post on it. So I'm still claiming this is the idea that we came up with, and they didn't tell us anything about this whatsoever. DynamoDB table, and then you have a trigger onto an AWS Lambda function. So essentially, you have a table, you push something into it, doesn't matter what it is, and then the Lambda function does the work of. It's like a stored procedure, but if anyone calls it a stored procedure, I'll hit him. It's not a stored procedure, it's still code, it's completely different. But if you think, logically, it has that kind of idea about it. So you take the data, you do something with it, and then you push it somewhere else. So Kinesis is, so DynamoDB streams, which is when you do a DynamoDB trigger, it pushes into a DynamoDB stream. And DynamoDB stream, sorry, it's very complicated, is Kinesis underneath it. Yes? Does that make sense? It's kind of, it's just another name for it. It's a special case. Say again?
I'm using S3 trigger onto Lambda.
Yep. Yep, that's a perfectly reasonable thing to do. Although we don't use S3 too much. So one thing I didn't say, which I think is quite important, is that most of the cloud providers who talk about function as a service and serverless provide you with scenarios where they do a lot of scaling. Those are actually not very good scenarios for most of what people need to do, which is why I think the take-up has been a lot slower than it should have been. I think people should consider small functions, essentially, and not think about it being scalable, and just, it is scalable, isn't that lovely? So things like, so has everyone, have people seen the chuck a file onto S3 and then do some processing on it and then push it? Yeah, that's the classic function as a service thing. I think that's not a very good use case. I think there are significantly better use cases out there. Anyway, so you've had your hand up many times. Go.
I was wondering what the development environment is, the life cycle.
Okay, so the development environment is essentially the same as you would otherwise have. So we have a JavaScript IDE. We use WebStorm. You could use anything. And we have various tools around that. When we originally started, which is the comment I was making earlier, we didn't have very many tools at all. And we were basically using grunt tools and various different bits and pieces to do that. And it was a lot of command line work. And now we're seeing a lot more tools coming out from various companies who are building the world around Lambda. So the tooling that it's what you would normally see, except for you can't do system tests. You can do unit tests, they're a lot easier. You can't do system tests and integration tests in the same way. You have to have a staging environment for that. So you have to actually deploy it, because it's very difficult to run what are essentially services on your local machine. So you have to think quite carefully about deployment, which is why Terraform's come in for us. Does that make sense? Go on then.
I'm not from this background, so it's
Yeah, that's absolutely fine.
question, but how can you do debugging in this kind of environment? I come from a C++ background.
Yeah, no, absolutely fine. No, previously, I'd have said you couldn't. You would have had to have done, so debugging in terms of which part of debugging do you want to be able to talk about?
So say for example, you think it's working, but when you deploy it on the AWS or whatever, and it's not working, or it's working for 10 users, and when you test it for 1,000 users, it's how you debug that kind of scenario.
So you have to, it's going back to the CloudWatch logs, so you have to work on your CloudWatch logs and understanding how to integrate well with your, and understand CloudWatch. So you can set up alarms on it, you can do a whole bunch of that, but the other thing you can do is you can download the log and do something, but that's often quite slow. So what you end up doing is you create log messages for yourself. So you actually end up creating customized log messages, which sounds like a bit of a pain, but that's pretty much the only way you can do it on a live server. But the thing to really consider is the fact that actually you build each function that you build is very self-contained, and we do a lot of unit tests. So we do an awful lot of unit testing. We do a lot less system and integration testing. So when things fail, they don't tend to fail across the whole system. They tend to fail in a very narrow space. So you can generally spot a failure very quickly, and you know where it is. So you can then basically, most of our Lambda functions are less than 100 lines. So if you can't debug 100 lines pretty much by looking at it, you know, there's something wrong with the entire system in terms of the way that it's been architected. That's a whole other problem. But most of the time, it's the unit tests don't catch something, and it's very, very quick. So we've hardly had any scenarios like that, purely because we've done an awful lot of unit testing. Does that make sense? Yeah. There's a whole other conversation around that we can have a chat about later. Go on then.
So roughly, how many Lambda functions do you have, and what's the complexity of your application?
I wouldn't say it's that complex, but there are reasons for that. We have, I think, 48 Lambda functions, which I think is something 40-something anyway. But I wouldn't say it's that complex. And I think the reason for that is, I mean, as a CTO, I don't want to build things that we have to maintain and manage more than we need to build and maintain and manage them. And when you are talking about and much as I don't like the idea of a minimum viable product, I was talking to think about something else, an MVP, there is real sense in building only what you need to test the theories of the market and go beyond that. So that's the approach we've taken, and I basically told people they're not allowed to, within our small team, they're not allowed to build things unless we've got a justification to build them. So we are very careful about not building something that's unmaintainable for the team size that we have, which is tiny. So have I answered the question? I can't quite remember what the question was.
The number of functions.
The number of functions. So yeah, we have 4, but most of those functions, I think the longest is 200 and something lines. So from that you can extrapolate, we actually don't have that much code. But it runs an entire system.
So what does the application do, roughly?
Yeah, so the application, it does things like manage user information, manage application configuration, because it's an Android app primarily. It manages credits, so it has a whole credit management system within it. It manages top-ups, callbacks, client interactions. I think we've got something like 20 APIs that we pull in. So we're doing a very small amount of work in each one. We don't have any one big bit of code that can fall over. So as I said, if we have one problem, it's usually in a very small bit of code. Go on. Yeah.
It's more commercial. At the moment, you're very linked into Amazon.
Yes.
Is there any sort of viable competitors?
Yes.
Whether it be federated or a single vendor?
So competitors, AWS does, so we're talking, if we talk just function as a service kind of model, so AWS Lambda and that kind of idea, There are 4 main competitors. There AWS with their Lambda functions. There is IBM with OpenWhisk, which is open source and very interesting indeed. I recommend you all look at it. There is Microsoft and Azure Functions. The fact that it's Azure is neither here nor there. They call it Azure, and we have to go with that because that's what they call it. You were asking about debugging earlier. Azure Functions has actually just released an extremely good debugging environment for live functions. So that's actually, so if you're in the Azure environment, have a look at it. It's really interesting and very, very clever. And the other one is Google, and they have a cloud function environment. So there are 4 main competitors within this space, but they're also pushing Firebase. So there are competitors within this, definitely competitors within this space, but they're all basically talking to one another at the moment, figuring out exactly how they can develop these scenarios so people like us can develop better things on them. So it's commercially, they're all still figuring this one out, but it's definitely going to be where they want to go because of the way that the servers make their systems more efficient in the system.
So this could potentially not necessarily always be public. You could,
Sorry?
well, it's not necessarily always public. Some of these services could be private.
Yeah, so I know of a number of very large organizations that do a whole bunch of this internally. So for example, one company I know has a whole series of Lambda functions to check for, they download files into their S3 bucket and they do an awful lot of checking for viruses. So they do that within code and they do an awful lot of other things as well within those Lambda functions, which is not an obvious use case, but it was a really interesting one when I heard about it. So there are a lot of people who do stuff internally, but don't use it as a system to have in front of a web front end. And there are some really interesting tools out there for doing cool things, and I think this will make a difference. So there was one question over here. Go for it.
Not as much as a question, but I want to say to the debugging thing. I don't remember exactly if it was the Google's function interface or just their cloud services, but they had some very good debugging tools. You can put breakpoints into your code and it will stop with the context it had without blocking the actual request that triggers it.
Yeah. So the interesting thing is about Google is that they're the ones who aren't talking to the community very much at the moment. They're doing a lot of their own stuff and putting their own things out, but the community is very much focused on AWS Lambda primarily, but OpenWhisk and Azure Functions are coming up on the side in terms of that. But I think Google are doing some very, very interesting things as well with this space. There was one other person. Oh, there's 2. I shall go.
You mentioned you like APIs and services, but then you hate frameworks.
Yes.
I kind of find that with more APIs and frameworks and services, you need frameworks just to make it.
Yes. So let's separate out 2 things: a framework and an SDK. Yeah. You need good SDKs. So if you have a service nowadays with an API on it, you pretty much need a decent SDK for anyone to be able to use it. What I mean by frameworks is things like Django and Express and Ruby on Rails and things that include the whole gamut of technology that you need for an application. Because the reason that these are problems is that most of the time what people do is go, I'm going to use Django, and then they walk into their SSH login and they'll type in whatever the command is, Django admin start or create app or whatever it is, and a whole bunch of stuff gets created. Now, if you don't know what that does, what you've just done is create a whole bunch of technical debt. And that's the problem with frameworks, is that they might actually be perfect, but you can't guarantee it for the future. And the less code you have, from a CTO point, this is me thinking as a CTO, the less code you have to worry about, and the less you have to worry about services. So someone else is managing the database, someone else is managing the scalability, someone else is managing the session management and the authentication. All of those things just disappear from your framework. You take that out, and the framework is basically a little bit of logic here and there and pointing at a template every now and again. Do you know what I mean? Actually, what most people use frameworks for is about 10% of what the framework does, and the other 90% is hoped. I hope this works. It's basically what you're doing most of the time. That's why I don't like frameworks.
It's sort of like WordPress and plugins.
I hate WordPress. Does anyone like WordPress?
Good.
We would have had a problem. But yeah, I cannot stand solutions where you're basically spending most of your time on maintenance. So my mantra with building our startup, when I did it, was I just want to reduce all the maintenance possible, which is why I can go on holiday and there's only a tech team of 2. Do you know what I mean? You think of pretty much any other startup with a Django stack or this or that or whatever, and you imagine a tech team. Exactly, you imagine a tech team of 2 running it, and you'd be like, that's terrible. Whereas the 2 of us are basically capable of doing pretty much most of the things we could ever want to be able to do. So one of us going on holiday at one time is no big deal. See what I mean? That's my mantra with AWS. It's not perfect. There are times when we have to do stuff, but the times when we have to do stuff, what we have to do is so small. I've never been rung up in the middle of the night by an automated system telling me something's gone down. And I doubt I ever will. Right, one more.
I think there is a right tool for right purpose,
Mm-hmm.
and kind of people should read the documentation, not just common world stuff.
Yep, I agree.
Many times how people execute thousands and thousands of even millions of lines of code, while everything could be done like in a few lines, and they just don't understand why.
Yep. So I would agree with that very strongly. I think the problem with frameworks is that they allow you to do too much too easily without understanding what's going on. I think so. A quick story. A couple of years ago, I met a person who was doing some work for a startup I was working in, and he then spent 2 days trying to get a piece of data out of the database into the right format, basically into a right structure, so that he could then push it into something else. He spent 2 days doing it. I sat down and I said, "What the heck are you doing?" He explained it to me, and I said, "You know that's just a SQL query, don't you?" And he said, "What? What are you talking about?" And the point is that people are Django programmers, they're not Python programmers. They are Ruby on Rails programmers, not Ruby programmers. And the problem isn't necessarily that the frameworks don't do some very clever things. It's that the people that use them are not clever enough to understand the right bits of the framework that they should use. It's exactly what you said. They don't consider that these things are simple in another form. And that's partly experience, but partly knowledge as well. And as soon as we start abstracting our knowledge towards a framework, you then lose the ability to be a good engineer underneath it. That's my opinion, and I get to speak in front of the camera, so you can all wait and talk to me later. But I agree. There's a lot I agree with about that's good about frameworks, but I just think there are going to be better ways of doing things. One more question, last one.
Can you give us about 3 or 5 examples when not to use Lambda?
I can give you one quick. Well, I did mention one, which is low latency solutions. It's not particularly good for low latency. So if you're doing a banking system, don't touch it with a barge pole because you've got to understand it's putting stuff up. But apart from that, when you need so if you're doing stuff with WebSockets, you can't do that with this. So that kind of a scenario. But it's basically anything that's HTTP based and can be done via async in some way, shape, or form. You're probably okay as long as you code it well. High volume of traffic. There are scenarios where really high volume, you probably want to get some servers and do it on your own solutions. But it's not the scenario where you go from here to here to here. You go from, well, this is the AWS Lambda solution, so let's put it onto the big solution now. Does that make sense? That it's not there's no upgrade to major and then big. It's basically, it's pretty big now. So you go big pretty quickly if it does explode. But for most startup scenarios, I think this is probably a very, very good way to go in terms of cost and in terms of scalability. That was it. I can see lots of questions. Do you want to? Thank you very much.